Hello, I'm David. I'm the product manager of the SMEMA Ethernet adapter. Today I'm going to show you how to control the SMEMA interlocks via the serial port. I'm using multiple version 81, SMEMA extension version 17 and serial port version 6. The use case is more local control of the SMEMA interlock. We've got a number of customers using it for inspection systems where the inspection system above a conveyor needs to control the conveyor. Other scenarios are where people already have existing MES connections, interfaces, so simple software can control the interface of the adapter. This concept can be used for any data connection, simple data connections such as network sockets, HTTP REST requests and posts, and in the future it will be the CFX connection will be the obvious use case. So the first thing we need to do is actually establish a connection to the serial port. So if we go to the settings, we go to the serial port. We go to the serial port of the adapter, we can enable it, such as that, and then for this demonstration I'm going to use PuTTY, which is a very well-known serial port application. Of course, if you're creating your own application, it will be mimicking the communication between the serial port and the adapter. So I've got PuTTY down here, I've got COM port 1, I've got the speed, same as the baud rate of the adapter, and I'm going to open that. I'll put that down in the corner there. So to test that we have a good connection, we can go to status, we can go to verbose logging, and I can type some characters and I can see that those same characters are now being read. And there's other ways of setting up the serial port. So you can, for example, at the moment it reads existing anything in the buffer. It reads out. If you want to read to a control character or a line return, for example, you can use a read to value there. So we've got a connection established with the serial port. We now need to subscribe to a blocking event. So if we go to subscriptions, SMEMA extension, sort by group, lane, let's go to Interlock good baud block. And go to that and we go to the subjects. The subjects are the data that is created on each event. If we go to blocked, we can apply that, we can save that, and then we have to do a deploy which connects the different extensions together. We now need to go to set up the actual blocking event. So if we go to the SMEMA extension, we go to the lane, we go to the interlock. If we scroll down to the bottom, we see good baud, block and unblock. So this is the event that it gets occurred, and this is the one we've just subscribed to. So the subject of blocked we've already subscribed to, and here this is the values that will come out of the blocking event. So if we wanted this to be a different value, we can just change the value here. So at the moment when block occurs, it will just be a true, but you can obviously make that more appropriate to your systems you're communicating with. And we can also enable if it's going to be, if the event's going to trigger on the block or also the unblock. Let's just do the block for now. So we save that. So we're expecting a true when it gets blocking. Now let's go to the main user interface. And at the moment we have no I/O from the up line to say there's a good baud ready. But the block isn't engaged, as we see here. We can disengage it using the user interface, but there's nothing going through at the moment. There is a machine ready, and that's been passed down, and that's got a lock enabled, which means it will never be blocked and never be interlocked. So if I now mimic the good baud signal upline, we can see the signal's being passed through from the upline machine, it's being blocked, and as we see in the serial port output from PuTTY, we can see the value is true. Now, how do I unlock that block? So if I put it back to how it was, we need to do the other direction. So we've got the data going to PuTTY, so outwards, to say there's a blocking occurred, but now we want to control something. So if we go to settings, the SMEMA extension, the lane, the interlock, we can go good board interlock control, and we want the value from the serial port to be passed through to this interlock control. So if I go to the serial port, if I go to serial port, there's subjects and just the value. So whatever comes out the serial port will go to here. So if we go to apply, and then we have the option to say what the value will be. So we want there to be a value for unlock. So I'm just going to use G for good. And if we save that, we now need to deploy it because we've changed connections to the events. So we'll deploy that. And now we see it's connected. So the subscription is the serial port. And to unblock it, we're going to look for a G. So if we do that process again, I'm gonna toggle the good board. So once again, I've got true. Now if I type in G in the PuTTY software, you can see the interlock's been unlocked. And now the downline machine is getting a good board ready, and then at that point the board will be moving down the machine. The good board signal will be removed from the upline, and the interlock will be re-engaged, and the process will happen all over again. The next board will come along, we get a true, we do a lookup, we say that's fine, and then the interlock is removed. So of course all the actions of the interlocks are in the settings area of SMEMA, but this is a demonstration of how to control via the serial port. All the major settings of what it's looking for are in here. So if I wanted to block again, I could use another value here. In that situation, the latching lock isn't being applied, and so you can change the startup values here. But ultimately, what it's looking for is some string values to say unlock, block, or any sort of control to do that. If the board was bad, you can divert on, so that will change it to a bad board, and as soon as the I/O goes low, the interlock would be reapplied. Of course, you'll need the data from something else. You might need the data from something else. In an inspection system, you are the data. You know what you've inspected, and you can process that board. But if you want to, for example, a barcode, you would have to attach the barcode reader to the adapter and map or subscribe from one serial port, because it will be a serial port that you would connect the barcode reader to the adapter serial port, and simply the data will flow through before the interlock situation will occur. So you would have to place the barcode reader before it gets to the end of the line. There might be in the future possibilities of creating a barcode queue, so when the blocking occurs, the data is sent at the same time. The current solution is to use the barcode reader completely disconnected from the blocking event. However, I predict that in the future there will be a barcode queue as there is on the Hermes adapter software. And I'm saying that because obviously you might be watching this in the future. So I hope that helps, and that will help you control the Interlock via third-party applications. Thanks for watching.